As the last speaker of this workshop, it's only appropriate that I extend my thanks to the organizers, and I believe it will be in the name of everybody else, but we'll have another concluding sessions to do it. And I must apologize to all the previous speakers in whose talks I've missed because of my teaching and other obligations, so sorry about that. And we'll proceed to our topic. We have here this cartoon in which the robot says, I love it, but I thought it was going to drive itself. For some of us, it's funny. We smile, we laugh, but what's so funny about this? I'd like to explore for a moment the intuition behind this cartoon. What makes it funny or strange or intriguing? What's in there? So behind this, there is an intuition and several intuitions about the nature of this robot. Because on the one hand, if the car is indeed autonomous, it drives itself, then the thing that drives it, so to speak, is a robot. In fact, an autonomous car is a robot. There is no robot that drives it. It is the robot. And we, so to speak, sit on the robot like this. So if this is a vacuum cleaner robot and the dog sits on it, this is us sitting in an autonomous car. This is everything that there is to it. So there is nothing that this robot adds by driving this car. So on the one hand, we think, well, this robot is like a car. We know that. On the other hand, this situation brings to mind the idea that there is something in common between the robot and the guy that sells the car. The robot has something human to it. In fact, it speaks like a human, right? We could place a person there saying the same words, and then the person would express a disappointment about the nature of this car. I wanted an autonomous car, and you're selling me a non-autonomous car. So there is something human about this robot. There is something human about what the robot says, and we understand what it is. And it's strange, it's intriguing because it is a robot that says it. Exploring these ideas will teach us both about robots and the way we think about them, and about what we learn about ourselves by exploring robots. Because this is why robots are so interesting, so important in the philosophy of mind. Because by learning what robots are, in what are they similar to us, and in what are they different from us, we're going to learn a lot about ourselves. And so the lesson that I will want to convey here is actually a lesson about ourselves. But I will speak about robots. Okay, so the word robot was coined, sorry, I'm going back all the time. So was coined by Karl Čapek in a play that was written in 1920, where it came from the East European word for work, labor, in the Czech language, more like the connotation is of serf labor. And in this play, there are these three creatures. Is this 1, 2, 3? They are mass-produced, and they are emotionless. So this reminds me of Othniel's talk, where the unexpected is explained by emotions. In these robots, there is nothing unexpected. They are all exactly the same. There is no aberration. We know what they're going to do, and they are produced in order to work for us. And this is actually the intuition behind the word robot today. We create robot in order to do work for us. Of course, not all the robots look human. Sorry, I'm going backwards all the time. These are industrial robots most of the robots are like this. They're not like this. But these robots don't seem to teach us anything about ourselves. So would we learn something? Would the intuition behind the cartoon be challenged if we just take these robots and put a doll on them, make them look more human? What's going on here? Why is this robot so human and these robots not? Just because the way they look. Both are robots in the deep sense of the term, which I'll discuss a bit later. For example, robots like these bring up ethical questions, whereas these don't. But these are machines exactly like these. The intuition, the science fiction, the popular culture idea is that when technology will be advanced enough, the robots will look like those and will be human-like. It will be hard to distinguish between them, between these robots and human beings. In fact, in Blade Runner, the previous one, this figure, we know at some point in the film that she's a robot, but she's not aware of herself of being a robot. And some things are around this theme of not being sure and in fact, what's the difference? Even if you know it's a robot, it doesn't make a difference, and so on. And this guy here, in several chapters of Star Trek, his status as having human rights is challenged, and so on. So the popular idea is that robots that also look like human beings, not these industrial robots, there is something human about them. It's challenging. We need to answer ethical questions about them. And there is something that we can learn about ourselves when thinking about these robots. The idea that I'd like to bring here to discussion is the following. Normally, in philosophy as well as in popular science and popular thought, these robots, the idea that there can be these robots that are similar in many ways to human beings, means that it's not only that these robots are similar to human beings. In fact, if we reverse the direction of the equation, human beings are similar to robots, because similarity goes both ways. If robots are similar to human beings, then the human beings are similar to robots. Human beings are not similar to any robots, not to these industrial robots, but they're similar to these robots. And if we discover this similarity, we will learn something important about ourselves. Of course, it's not the external appearance. This is superficial. Dolls can be similar to human beings, and we don't have ethical problems with dolls. The thing is that these dolls, and they are dolls, these dolls behave in a way that reminds us of human beings. More advanced robots, the most advanced robots today, can speak. Of course, you can immediately detect that they are robots. They don't pass the Turing test, none of them even remotely so. But still, they become more and more advanced every year. And the aim at the end of the way is to have something like this. And why not? I mean, technology pays to technology. If somebody succeeds to build such a robot, it will pay. And people make huge efforts to build them. And why not? So let's imagine that we're going to have such robots. Maybe if we open them up, we'll discover that by looking at the inside that they are robots. Maybe not even that. Who knows? What's the limit? When is something a robot? When is it a new species? And so all these questions come up. And the idea is that the popular picture, when I say popular, it's prevalent also in philosophy of mind and among scientists. This is how popular this view is. And so the popular view is that, that robots like these, advanced ones, complex ones, and human beings are very, very similar, if not exactly the same thing, in many important ways. And this idea is taken to be scientific. That is, the scientific way of understanding human beings, what we are, what is our essence, what makes us who we are. The scientific way is to learn, is to understand, to realize that we are no more than robots. If we're more than robots, this would mean that we have souls that are immaterial, non-physical, supernatural, blah, blah. So there are these two options: immaterial, supernatural souls, or robots. So this is science. And what I would like to try to convey in this talk is that this is a non-scientific idea, in the sense that if you say that robots, in the way that I'll discuss in a moment, are like human beings, by saying that, you assume a supernatural soul, a non-physical entity. This is not science. This is the idea. So the thing that is taken to be the paradigm of the scientific understanding of human being is not science at all. This is the idea. And now I'll start to be a bit more technical, more not as picturesque as this. And to start with a very brief background, I want to say a few words about what being physical is. When we say that an object, a person or a robot, is a physical entity, what do we mean? So this is just an image. I don't need this anymore. The background, physicalism. That is, what do we mean by saying that a person, for example, is completely physical? There is nothing except physics in a human being. So there is an object that is completely physical in the sense that it is made of atoms and nothing else. We can fully describe that object by describing the atoms, the subatomic particles, the interactions between the atoms, blah, blah. All of that is a complete description of that object. Presumably, we can give a full description of this bottle of water in these terms. So physicalism will say that the same goes for human beings, robots, and everything else. But of course, when we think of a robot or a human being as a physical entity, and we want to ask, what about this system makes it, for example, conscious, or having an experience, things like that, have something mental about this? Well, in physicalism, we would say that not everything about the body will make it conscious, but something, some aspect of the brain. So there is some aspect. Not all the robot is like this, not makes it mental. Not all the human body makes it mental, but something about it. So there is an aspect, call it P, because we're going technical, of the physical token, of the physical particular state of affairs at a given point of time, that is associated with the computers or the robots or the person's computational state S. Computational state, the robot computes. At each point, it has its computational state, which is allegedly, by this popular view, parallel to the computational state in the brain, because the brain is to the mind as the hardware to the software. We are like robots. So there is something in the brain that makes it, that is the conscious experience, and there is something in the, or that is some computational state, and there is something parallel to it in the robot or the computer. This is physics. We don't need more than that. And the question is, how do we describe robots and human beings in these terms? Case one. We're not going to compare between two computers, not a human being and a computer or robot, but two computers. For example, the computer that is right here on the podium and a computer that any of you has. For example, Yossi's computer is clearly different from this one in terms of its hardware. The hardware is different, slightly or radically different. There is some difference, and the difference is in both in the irrelevant parts. For example, the keyboard is physically different, but there is something different also in the heart of the computer, in the chips. They are different. They are made by different manufacturers, and they are different. But nevertheless, they run the same software. We can run the same, for example, word processor on the same document in both computers. So the case study one is what is similar, what is the same between the two computers that have a radically, let's say, for just to make it clear, radically different hardware, but run the same software. The same, both run Office word processor on the same document. So one way of understanding what's going on when in this case study is this. We have two objects, the blue and the green, A and B. Both run the same software on the same document. They share some physical aspect. There is something the same, something that is exactly the same in these two computers. Not approximately, but exactly the same. This is why they are the same in running the same software on the same computer. Not all of them. They're not similar in everything, but in that aspect they are. And there is another computer that cannot run this software. It doesn't do the same thing. Okay, but these two have to have something identical between them, and that thing that is identical between these two computers explains why they run the same software. This is a type identity explanation of what's going on. Okay, next. Suppose now that we look closely at the two computers, A and B, and find that they have nothing in common. They are radically different. They are heterogeneous physically. They don't share any physical property that can explain how it can be that they run the same software on the same document. How can this be? The prevalent view goes by the name of multiple realization. That is, they are heterogeneous physically. Nevertheless, they do the same thing. Why? Well, there is a mysterious brute fact. We don't understand what makes it the case. How can this be? We don't understand. It's just a fact. Look at these two computers. Can't you see that they run the same software on the same document exactly? There is nothing physically identical between them that can explain this. So it's not explainable. It's just a brute fact. This is called, in the literature, multiple realization. Both computers realize the same software on physically different substances. This is mysterious. This doesn't look good to one who wants things explained not by brute facts. Brute facts don't sound like physical explanations. But there is a very simple physical explanation, which is this. There is an observer. When I look at Yossi's computer and mine, I interpret what I see as the same thing. His output can be on glass and mine on plastic. But to me, because of the way I interact with these computers and the way this interaction then is mapped back to my brain, I interpret these two computers as doing the same thing, as having the same output on their screen. It's not there. They are completely heterogeneous. I make them similar. So this is a very simple explanation of why two computers are the same, and this is in fact what happens in contemporary computers. They are very different in their hardware, but we learn to understand them and to manipulate them in a way that to us functions as if it was the same. It does the same thing as far as we are concerned, not out there. So there is no multiple realization. There is a type identity. There is something physically the same exactly in both of them, namely the state of my brain, not in the computer, but my brain is in exactly the same state in both cases. So we have a full physical explanation of why two physically heterogeneous computers carry out the same program, the same process, the same computation. There is no mystery here. End of case one. We now move to case two, where we no longer compare between two computers, but between a computer with a doll, namely a robot, and me. And the question is, can we say that the robot and I carry out the same computation? Because it is the prevalent view, or one of the prevalent views in contemporary science, is to understand the mental functions of human beings in terms of computations. So there is a computation going on in our brain, there is a computation going on in the robot. This explains why, in this sense, we are the same. By the way, in Michael's talk, he presented a different line of thinking in contemporary science, which looks at the biology, the physiology of the brain, of the body, and not as a computer. So this is a different paradigm, a different line of thinking that goes in parallel in contemporary science. So I'm not going that direction. I'm talking about the computational view of the mental. And so I'd like to compare between the robot and me, where me is understood, my mental experience is explained in terms of computation as in the robot. Okay, back to same diagram, same figure, same illustration. So case one is where the robot and I share the same identical physical features. So the robot does not mimic it's not similar to me, but it is a complete replication and precise replication of the physical aspect of me that gives me the mental experience. So whatever in my brain is the mental experience must be copied completely and with perfect precision to the robot. Otherwise, the robot will not have a mental state. It has to be the same physical aspect, has to be repeated, copied in the two systems. But usually this is not the way we think of robots. We think of robots as made of radically different hardware, but nevertheless carrying out the same computation as our brains do. So what we have in mind actually when we think of robots is this case. So there is a robot, there is me. We are radically different in our hardware, and nevertheless there is something similar about us. I'm talking about these advanced science fiction robots that will be in the future. They will have mental states. They will even have emotions. They will have feelings. They will have thoughts. That they will have something mental about them. So the idea is that, the thought is that despite the radical physical difference, there will be something common between the robot and me. And my question is, what is that thing? What is common between the robot and me in virtue of which we are the same in our mental experience? Well, the prevalent answer is, again, that in terms of if there is physical heterogeneity, there is a multiple realization. There is a brute fact. These people will tell you, well, look at these robots. Aren't you convinced just by looking at them that they have mental experience exactly as human beings? The problem of other minds may be brought into this discussion. I will know that the robot has a mental experience in the same way that I know that you have mental experience. But with respect to you, I can say, well, physics can explain this. We have the same brain, so why not? But the robot doesn't have the same brain. So what about the robot makes it the case that we have the same mental experience? There is nothing common physically. Well, let's repeat the trick that we did in the previous time. In the previous time, recall, when we compared between two computers, we say that it's not a problem if they are physically heterogeneous. They can nevertheless be the same because when we observe them, we interpret them as running the same software. Why not do this here? So, okay, let's do it. There is an observer that observes the robot and me, and in virtue of that observer, we are the same. But that doesn't sound as good as in the previous case, because here we're committing the homunculus fallacy. We are saying that I have an emotional experience or some other mental experience because somebody, maybe in me, is looking at me and making it the case that I will have, by looking at me, will make it the case that I have this mental experience. But what is that creature? What makes it the case that this creature has this mental state that makes me having, that induces that mental state in me? Well, that creature has its own mental state, and we are into an infinite regress. So we cannot use this trick in order to explain in virtue of what, physically, there is something in common between the computer and me. This doesn't work here. And so we have to go back to something like this. The only physical explanation will be that there is something physically identical between me and the robot. But then people say, well, look at these robots. There is nothing physically the same between us and the robots. We are physically heterogeneous. And nevertheless, we are identical. So I'm asking, in virtue of what are we the same with the robot? What makes us the same in the sense of mental states? And if this trick is unavailable to us because of the homunculus fallacy, there is only one way, and it is this. There is something non-physical that we share with the robot. And it is because there is nothing physical that we share, but we share something. What is it? It's something non-physical. And if you don't want this ghost in the robot and in us, well, have something else outside that looks at us and makes it the case that we share the same mental reality. So in order to say, as many people do, that our mental experience, including all sorts of all the variety of mental experiences, in order to say that these are fundamentally computations, when we say that, we endorse either property dualism, which is this, or substance dualism, which is that. And this is clearly not a scientific view. Thank you.